The world's largest copper refinery recovers nearly 40% of its material from recycled inputs. This facility converts electronic scrap into high-quality, marketable products while minimizing environmental harm. Copper can be recycled without any loss in quality, ensuring the raw material remains of the highest purity, even if the initial smelts may contain notable impurities. Electronic scrap recycling is a long-standing tradition that has existed for decades and enables the recovery of precious metals such as gold and silver from scrap during copper processing. The refinery initially specialized in processing gold and silver. However, for over 140 years, the smelting of copper ores has dominated production. Throughout this process, samples of the copper are taken repeatedly for precise analysis. Once the valve is opened, these samples are cooled under pressure. After cooling, they are sent for analysis to determine the copper content. The smelting process is a precise and dangerous operation, with each step carefully controlled. Only the smelters are permitted to move freely, as the red-hot slag, although containing iron, is much lighter than copper. This causes the slag to float to the surface, where it is skimmed off. The process occurs in the flash smelting furnace, where copper, iron, and sulfur concentrates are smelted together. The iron is oxidized and converted into iron silicate stone during this stage. Remarkably, in this process, nothing goes to waste. The molten material is cast into enormous molds, and the heavy chunks are later used to reinforce riverbanks. After the initial smelting, the copper is further purified in converters, where air is injected into the molten metal to oxidize and eliminate remaining impurities. At this stage, electronic scrap rich in copper and precious metals is introduced. The computer scrap is fed through a side chute, and air is injected into the melt to ensure efficient utilization and combustion. Processing electronic scrap in the copper smelter helps manage potentially harmful elements released when burned. The pollutants from the computer scrap are insignificant because the sulfur-rich exhaust gases generated during the smelting process are meticulously filtered before being released outside. The facility's filtration system, known as the contact plant, filters all the processed gases over 300,000 cubic meters per hour. Without this system, exhaust gases would escape directly into the air, which would be unacceptable. Computer scrap maintains a solid commitment to environmental protection and can only be recycled in environmentally responsible ways. Computer scrap melts into slag when burned at high temperatures, separating it from the production process to ensure cleanliness. Simultaneously, sulfur in the gases is converted into pure sulfuric acid, which the refinery utilizes as a byproduct of environmental protection. The control room evaluates the acid, which is twice as heavy as water and highly corrosive. Once metal is completely freed from sulfur and iron, the smelters cast large copper plates known as anodes. These 408-kilogram plates are poured into molds, where the surface solidifies as water is sprayed to clean them because the water evaporates instantly. However, the raw copper still contains nearly 1% impurities, requiring further purification. Therefore, the anodes are processed in a massive hall where workers deliver 3,400 anodes daily. The final purification process takes over 3 weeks, during which the massive copper plates dissolve in a warm acid bath, assisted by a significant amount of electricity. This process, so-called electrolysis, is powered by a low voltage of about 300 millivolts. This is a safe and efficient method for removing the remaining impurities. In this process, copper and stainless steel plates hang close together in an acid bath with a direct current guiding the copper. Only pure copper deposits on the stainless steel plates, while the impurities settle at the bottom and are later processed separately. This waste contains precious metals that were previously melted by electronic scrap. The electrolyte is heated to around 63 degrees Celsius using steam for metallurgical reasons. Although the heat and humidity can be noticeable, the smell poses no harm to humans. The result of electrolysis is pure copper at 99.99%, which is collected as the final product. The refinery harvests pure copper weekly and immediately remelts it to produce its main products: rolling plates, round billets, and most importantly, finger-thick wire. Copper wire undergoes extensive quality control, such as twisting, to ensure it meets rigorous standards. The wire is ready for market use only when it passes all tests, including those required for high-demand applications like cable manufacturing. Like copper wire, the materials received in the goods are thoroughly inspected. After being weighed and traced, this material, such as scrap from printed circuit boards, for instance for use in mobile phones and other electronics, is evaluated for its metal content, including valuable metals like gold and copper. The recovery process involves extracting precious metals such as gold, copper, tin, lead, silver, and palladium in lower concentrations. A complex sampling process assesses the material's value and ensures it meets customer requirements before further processing. After analyzing the sample, the material is melted at around 1,000 degrees Celsius, causing plastics to burn off, while containing fiberglass mats that cause impurities in the molten metal. The remaining material is then pulverized in a ball mill. The resulting powder is divided into laboratory samples, where the elements to be paid for are analyzed. These samples are thoroughly analyzed to determine the concentration of precious metals. The slag, a byproduct of the melting process, contains no precious metals and is discarded as waste. The material is processed again in the second melting, and a small metal bead forms. A porous clay crucible absorbs the base metals, leaving behind a precious metal grain containing silver and gold. The silver is separated in acid, and the remaining gold is weighed. The difference in weight determines the silver content. This careful analysis is done at least 4 times to avoid errors and ensure accuracy. Additionally, the metal content in electronic scrap is the main factor financing the recovery system, as plastics alone wouldn't cover the costs. Without metal recovery, consumers would face significantly higher direct or indirect expenses. Gold and silver from electronic scrap are byproducts of copper production. 7 tons of valuable sludge are extracted daily from the copper electrolysis tanks and taken to the precious metal recovery area. The next step is to separate the non-ferrous metals in the sludge, but making the products pure is difficult. Once separated, the raw silver, which contains 85 to 90% of precious metals like silver, gold, and platinum, is melted. However, because it's too impure to be cast directly, it must undergo refining through a process called cupellation. These raw materials used for producing semi-finished silver products like silver wires and sheets are remelted and cast into silver anodes. These anodes then undergo final purification through silver electrolysis. Each silver plate, weighing about 50 kilograms, still contains impurities, so it is dissolved in a nitric acid bath for 2 days for chemical cleaning. This electrolysis process requires significant energy consumption. A low voltage of about 1 volt and a very high current of around 1,000 amperes are necessary to maximize silver deposition. The silver electrolysis process is unique because the precious metal plates are hung individually in bags, preventing impurities, like gold containing sludge, from mixing with the silver crystals. Silver does not deposit on the cathode. Instead, the crystals are regularly scraped off to prevent a short circuit caused by rapid crystal growth. The crystals are collected once a day. Each day, 3.5 tons of silver crystals are harvested by draining the tanks along the bright blue electrolyte, which is returned to the system. From an anode weighing about 45 kilograms, half and 2.5 kilograms of anode sludge are collected, then removed, emptied, and washed out. This sludge, containing gold, platinum, and silver, is boiled with nitric acid until all the silver is completely dissolved. This process is called refining. The silver is thoroughly washed, but touching is prohibited, as fine silver residues may still stick to the surface for days, weeks, or even longer. The most common form in which fine silver is found is the bars. Silver isn't only used to make jewelry, cutlery, and coins, and plays a crucial role in photographic films and papers. Similarly, gold refined to 95% purity is cast into small anodes weighing 3 kilograms. These anodes are rigorously inspected, and any with cracks are remelted to prevent short circuits during electrolysis. Only perfect plates proceed to gold electrolysis, where they dissolve completely within a day. The remnants are meticulously collected each morning to ensure maximum efficiency. The gold deposition process is rough, resembling sandpaper with no metallic shine. It appears dull, more yellow than gold in color. However, the material inside is smooth, like the surface of a titanium sheet, and extremely heavy. Each cathode weighs about 2 kilograms. Once folded, the sheets fit into a narrow furnace. At temperatures over 1,200 degrees Celsius, the gold flows through a preheated sieve. As a result, the fine gold that settles at the bottom of the water basin is collected and forms gold granules, which are a primary form of gold produced alongside bars. These granules are highly practical, easy to measure, and can be remelted for use in industries such as jewelry and electronics. Customers can easily measure gold in this form. Even if the smallest gold particle is carefully collected, strict security measures leave no room for opportunists. Additionally, the composition of gold allows its origin to be traced back to the manufacturer. Although electronic scrap alone does not contain much gold, the majority of it comes from copper concentrates derived from a single truckload of electronic scrap. Approximately 5 kilograms of gold, 20 kilograms of silver, and 4 tons of copper can be extracted from just one truckload of electronic scrap. This process is only worthwhile when dealing with vast quantities, an impressive feat of modern chemistry.